All right. How are you guys doing?
Doing good.
Ready for our
Feels,
last class?
yeah, feel sad. This is going to be the last one.
I know. We came a long way though, right?
Yeah.
Good. We did.
Yeah, it's been a nice way to get out and not go anywhere.
Cool. Well, did you guys have any questions with the final?
Yeah. I have a question. Actually, I realized in the past several homeworks, we didn't use the annual adjustment for the variation.
So,
Well, we should do that, right? In
so
reality.
the annual adjustment for the variation is in minutes.
Oh, okay.
And so it's so minuscule. And variation just needs to be to the nearest degree. It doesn't have to be point, 1, 2, 3 or whatever.
Okay.
So you can apply it, but it just turns into the whole degree anyways. Because it's such a small number.
Okay. All right. Yep.
But, yep, good observation. All right. Well, usually my last class, we go through a whole review of the whole class, which is the final assignment. We kind of go from week 1 all the way over. But I posted the video, so hopefully you guys can check that out and maybe that can answer some questions. So for today's class, I'm going to go over kind of a abbreviated review of what we do in CoNav1. CoNav1 is not going to be held until the fall. So this kind of a sneak peek. Again, you can take the class if you want, but I was just trying to help out since we have more learning time with the videos. Makes in-class person more lecture. Okay, and then I don't know, do you guys have any questions? Should we get started? All right, let's do it. So we have share. Oops. Okay. All right, so we are reviewing CoNav1 on our week 7, final week. So our big question is, why would our actual position be different than our DR position? Any ideas? I'd usually be writing them down, but throw some out there.
Well, this is a wind direction and current direction.
Wind, current, what else? Swell.
Yeah, swell.
Steering error.
Mm-hmm.
Or speed error. Poor plotting, mathematical error.
Didn't start
human error
from,
and that.
you didn't start from where you really were.
Yeah. Lots of reasons. But we're going to focus in on those and kind of bundle it together into a set and drift. And that's kind of the wind and this current and the swell kind of pushing us off. We're going to bundle that into set and drift. So first, in order to lecture about this, we're going to go over a lot of vocab. So under the current category, we have current. So current is the horizontal movement of water. Not the opposite of that, but tide is the vertical movement of water. Current is the horizontal movement of water. So when you say the tide is pushing me off the dock, that's an incorrect statement. It's the current that is moving you, that is pushing you horizontally. The tide is what is moving you up and down, changing the depth of underkeel clearance or the depth of water below, or the height, the air clearance to a bridge. So the current is what moves horizontally. Does that make sense?
Yeah.
Okay. Okay, so then when we look at current, we have set, and the set is the direction towards which the current flows. So set, my two little remembering things here, is which way does the sun set? The sun sets in the west, that's a direction, not a speed, where drift is a velocity. Set is a direction. So it's which direction is the current flowing. So if you had a northerly current and you were sitting out there in a little inflatable tube, you would be flowing towards the north. That would be your direction, 2. So here I put current to, wind from. So when you hear the wind forecast, you know, on your local news station, the wind is from. So if you had a northerly wind, it would be coming from the north, pushing you to the south. Where current is opposite. Current is pushing you to the north. So those are two different things. Drift is our velocity of current. How quickly are you drifting down the beach? It's a speed, it's a velocity, and we say that in knots. Ebb is when the current is moving away from shore or down river. So, or away from the harbor, out of the harbor. So the ebb, everything is coming out of the harbor, and the flood is when everything is coming into the water. Spelled that wrong. Oh, whoa. Current is mobbing. So the flood is when everything is coming in, and the ebb is when everything is coming out. And I'm going to show you a visual of this. Slack is when the current is nearly 0. So it doesn't quite have a direction or a speed. It's right in between where it was flooding. Now it's kind of slowed and stopped, and then it's going to start going the other direction again. So it's right in between that ebb, then it goes to slack, and then it goes to flood. Then it goes to slack, and then it goes to ebb, then it goes to slack, then it goes to flood. And it's a cycle. So sometimes you can say that the slack is 0, but is the water ever not really moving? It's the closest to 0 as it could possibly get. That's the definition of slack. Any big questions on the current so far? Okay. So tides. Again, tide is that vertical movement of water. So that's changing our bridge clearance or our clearance under the keel. It's the vertical movement of water. And we apply it to the chart depth. Did I put another one here? Nope. Okay, so the tide, if we say it's a 3-foot tide, it doesn't mean that there's 3 feet of water under you. It means whatever is plotted on the chart, whatever sounding is on the chart, you add 3 feet to it. You could have a negative tide. You could have a negative 2-foot tide. Doesn't mean you're seeing the ocean bottom. It means that whatever the charted plot, the charted depth was, it's below that. It's a negative 2-foot tide or something like that. So it's just a number that is applied to the chart depth in order to get the correct or a more correct sounding. The range of tide is the difference between two consecutive highs and lows. So from one high up here to one low, what was the difference? Did it drop 2 feet? Did it drop 20 feet? Different areas have different typical ranges. So it's between a consecutive one. So from high to a low, or from a low back to a high, that's the tidal range, from right in place, kind of in order. Stand is where there's no change in height of water. So that's kind of like a slack, but for tides. So as the water's moving up, it stalls out, and then it starts going back down, and then it stalls out, and then it moves back up, and then it stalls out, and then it moves back down. So right at that stall is what they call a stand, for the no change in height of water. Okay, so a spring tide, that's just a term of a time of the month when the moon is either new or full. The ranges are going to be bigger. So you're going to have higher highs, lower lows, faster currents, more things are happening during that spring tide. So you always, and that's where you get those king tides. I don't know if you've nicknamed, there's lots of different nicknames out there. But it's basically an increased range. And that range is from consecutive high to consecutive low. So your lows are going to be lower and your highs are going to be higher. Both. The opposite of that is the neap tide. And that is our decreased range or speed. Oh, I over there. Anyways, and that's when you have the moon is at the quarter. And that's decreased range. And so if you have your average high and lows, they're just going to be smaller, not as high and not as low. So if you really needed a high tide or you really needed a low tide, you would have to wait for a spring time to get that kind of bigger increase. So I think now I have my visuals. I like to draw my visuals out. Okay, so here we're looking at the charted depth. So this is what the chart says the depth is. And then this is the height of tide. And this one, it's a lot. So the blue line here is water at any given time. So the height of tide is applied to the charted depth. We also have a visual here of the neap range and spring range from your mean high waters and mean low waters. This is tides. This one I thought was cool. It had gave you a little fish. Again, you can just Google tide graph Newport Beach and you could probably come up with one. Does anyone use a tide app?
Yes, I do.
Suggest one to the class?
I use Navionics.
Navonics?
Yeah.
So
Anybody use anything else?
Magic Seaweed shows wind direction and tide as well.
Okay. So yeah, there's lots of different things out there. But you can see the cycle of it goes to low, and then it goes to high, and then it goes to low, high, etc. This one also gives you time of daylight, nighttime. Okay, so this one is of Long Beach, and you can see for us here in Southern California, we have this mixed or this semi-diurnal tide where in one day, it goes low, high, and then a little bit low, and then high again. And then low, high, a little bit low, and then high again. So our lows aren't, so it's not this perfect sine wave, kind of like this one where it's a sine wave that's very even. Our sine wave is not even. So when we do the rule of sevenths, if you've heard of that for tides, it's harder to apply to this mixed or semi-diurnal tide. This was another graph you can do. This one's Santa Monica. So you have the stand where it stalls. This is tide, right? So we're changing in feet direction, or feet height of the water. So it gets really high and then it starts going low, and right here, so this time period is where you're going to have the fastest moving water, the fastest current, and then the current starts to slow when you get to the stand, and then you're going to have the fast moving current again there, because you have the bigger difference. If you look at like slope, the slope is a lot increased during that middle time between each slack or stand. Does that make sense?
How much of that fluctuation is governed by the moon?
We'll show you a moon picture right here. So this moon picture is showing us the spring and the neap tide. So when the moon is in line, either in between the Earth and the Sun, or moon, Earth, Sun, you have more gravity pulling, and that's where you get those bigger tide ranges, excess, higher highs, lower lows. When it's at the quarter, first quarter, third quarter, they kind of balance out and you have the lower ranges. So that's where the moon is affecting you. But tides can be all sorts of the way the seafloor is, like up in Washington, Alaska, you have a tide range of like 22 feet. Here, our tide range is like 5 or 6 feet. Sometimes I've been places in the Gulf where it's like 1 or 2 feet. It's not much at all. So it really depends on the moon, and also I would say mostly the space that you're in, whether it's a bay, a river, an open ocean. There's no real tide change, open ocean. How is the coastline, sloping up steeply or super gradual? California has a much steeper increase versus the East Coast. They're very gradual beaches. All that kind of stuff can come into play there.
Pretty on the top half of the chart, what caused of this this kind of irregular shape for Long Beach area?
This is an example of the Long Beach chart.
Yeah, but what caused that irregular shape?
Oh, what causes it?
Uh-huh.
I don't know. I don't know what causes it. Anybody else? No?
Mother Nature.
Mother Nature. I don't know exactly.
Okay.
You could look it up, mixed tides. Maybe it says.
I think
What did you call that? What kind of tide was it that you called it?
So semi-diurnal.
Semi-diurnal.
Or mixed.
I think it has something to do with the ocean.
Hopefully not earthquake.
No.
No. Because this is what's really crazy, is on the Pacific side of the Panama Canal, if I remember right, you have the semi-diurnal with like a 12-foot range. On the Atlantic side, you have
Janice, we lost you on what happens on the Atlantic side.
and it's
What
that's
happens
why
on the
you don't get a
Atlantic
boat
side? We
slip
lost
on
you.
the Pacific side because the docks have to float too far.
All right.
We got half of that.
We got half of your story,
Oh,
Janice.
I'm sorry. I'm sorry. On the Pacific side of the Panama Canal, I think they have semi-diurnal with 2 highs, 2 lows each day. And the range of the tides is 12 feet, roughly. On the Atlantic side of the Panama Canal, I think it's diurnal, where they just have 1 high and 1 low, and the range is 1 or 2 feet. So I think it has something to do with the ocean itself, and there's a word which I think is SEICHE that helps to explain it, but I can't go any further than that. That's all I remember.
All right, something to look into.
Something, yeah, but I think it has to do with like almost like the shape of the ocean, and like you were saying, the seabed and those kind of features.
Yeah. Okay, let's move to currents, and then I was going to do ocean currents. Okay. So current graph is kind of similar. So this has flood up here, ebb down here. So the flood is when it's going into the harbor. Wait, let me get this one here. So this was so the flood is when everything is flooding into the harbor. The ebb is when everything is flowing out of the harbor. And then you also have what they call rotary tidal currents, where the current moves in a circle. Okay, so when we look at our flood, and then slack is the blue line, and then it goes to ebb, flood, ebb, slack. And this is Queensgate on the 21st, last Thursday. So you can see how the currents change. This is another example, has more of a change on this one. So you have all of your ebbs down here, your floods up there. No, I wanted to do another one. Oh, let me show you. Stop share. Screen share. Okay, so tidal currents is what we were looking at there, but there are also ocean currents. So ocean currents are your big typical currents. Does anyone know of any off their top of their head?
Yeah, the one from the Pacific coast, down from the north.
Yes. Do you know what that current is called?
No.
Anyone know what that one's called? Davison current. So that current is cold, right? Because we have a cold ocean. So if this is USA, this would be South America, Australia, and China. So ours on our coast is cold, so it comes down to the cold, and then it gets warm, and it goes along China's coast when it's nice and warm. In
Cool.
South America, the cold comes up, giving those regions similar to ours. And then in Australia, in the South Pacific, it gets warm, and it becomes this circle. So, kind of this circle effect. Now, if you do this, you could change these land masses that I've artistically made to make this USA, this Europe, Africa, and South America. So on the east coast of the United States, we have the Gulf Stream. That's a very popular current that comes up from the equator right next to our coastline, and it's very strong, sometimes 4 or 5 knots, and then brings you back over. So you want to know where these currents are and to either use them in your favor or to use them, or to, if you're going against them, to not be right in the middle of the current. So you either want to cross the Gulf Stream very quickly or use it to your advantage. Again, Europe, they have the cold waters because it's coming down from the poles. Then it heats up, brings us hurricanes over to the United States. Brazil, nice warm waters. West coast of Africa, cold waters. Does that make sense for ocean currents?
So you said the Davidson current, that's the one that's off the coast of
California.
our coast coming
Yeah.
down from Alaska?
Yes.
Okay.
That one's not as defined as the Gulf Stream. The Gulf Stream you could almost see, I don't know if anyone has seen it, I've seen it, where it's a total change of color where the current is moving. So yeah, you want to use it to your advantage and not against you. So that's ocean currents. Okay. Let's go back.
Yeah, the Gulf Stream, you can actually measure the temperature of the water and see if you're in the current or not, because it's so much warmer
Mm-hmm.
than the water along the shore.
Okay. Okay, so how do we determine what the current is? Now we're going to focus on current. So there's 2 ways that we could determine what the current is. One, we can use our navigation pubs or prediction calculators or apps or all sorts of different things, which get their information from the pubs. So that's very useful. Or we can measure the difference between our DR and our actual position to see what the past setting drift was, and then we could apply it to the future. So we create this vector triangle, and we are going to dive into that vector triangle. Does that make sense so far?
Yeah.
Okay, I might go back and forth to my my whiteboard here. Okay. Okay, so on our vector triangle, we have 3 legs of the triangle. Our first leg is current, and that's what we have set, which is the direction, drift, and that's the speed. So here I put in a green arrow. So a vector, if we go back to our high school days of geometry or algebra, I don't know, whatever. A vector has a direction and a length. So that speed, we're going to use 60D Street to give us the distance using the speed. And our quickest way to do that is to say this whole triangle is 1 hour. So our speed is our distance. We're going to be doing that a lot. So that's the first line is your set and your drift. So that's the current. The purple line is what your boat is doing. What you are steering and what your boat's speed is, speed through the water or speed by engine. Sometimes, well, at least on big boats, you can go, you know, half ahead, full ahead, change your speed by RPM. You're going, you know, 1,000 RPMs, how fast is that? 70 RPMs, how fast is that? And you might have, like, if you want to go 1 knot, you go this many RPMs. If you want to go 2 knots, you go this many RPMs, 3, et cetera, et cetera. Or you might have a speed through the water Doppler recorder. So that's what your boat is doing. And then your orange line is what we call the made good over ground or over bottom line. So that is what actually happened by your boat. Your boat was steering the purple line, but where the wake went was where you are on the orange line. So I think, nope, I don't have that. Okay. Okay. So let me go to the next one. So in this triangle, so now I have a triangle here, and we have our current and our boat, and this is our made good. So if our boat's traveling like this and our current is pushing us like that, then we could say, yes, this would be our made good. So here you can see I'm always traveling on my made good line, but what I had plotted was what my boat was doing. And so my boat is steering in this direction the whole time. Oops. But my made good, I'm kind of crabbing because of the current is so strong. Does that make sense?
Mm-hmm.
Okay. So when we have problems with or do assignments with our vector triangle and we're trying to figure out what the current is, I like to make a graph here. So the graph has 6 spots. You have your course made good, your speed made good. So that's your orange line, your made good line. And then you have what your boat was doing, what you were steering, what your speed was. And then you have the current, set and drift. So from these 6 values, you will be given 4. They might not all be on the same one. So it's kind of like putting the puzzle together. But you can do this triangle on anything, really. You can do it on the chart. You can do it on radar plotting sheets, maneuvering boards, universal plotting sheets. You can do it on graph paper. As long as all the units are the same, you can do it on anything. Okay, so the 2 ones that I have a star next to, those ones start from each other. So you can see the current and the made good. Those are the 2 that's happening like over ground. Those start from the center if you're using a tool, a plotter, or they just start from each other if you're doing it on the chart. So they start from each other or start from the center. Okay, so this one, here's an example. We want to make good due north, right? We want to make good due north at 10 knots. And we have a current of 0.45 at 2 knots. The current is pushing us this way, and I want to make good this way. So logic would tell me, yes, I need to steer to the left. If the current is coming, can you guys remind me, pop quiz, how would I describe this current in directions? Like northeast, south, or west?
Northeast.
The northeast current, because it's coming from the southwest to the northeast. So I have a northeast current and I'm headed, and I want to head north. Logic would tell me I need to steer over to the left. So I can complete this triangle and figure out exactly what course and what speed I need to do to make this work out. So let's do an example. Okay. So I wonder if I can split the screen. If you guys, so are you guys looking at a chart right now? Or like, how would I follow? I want to follow along with you guys. Here we go. So I have a couple examples here. I have, this is what they call a radar transfer plotting sheet. I know we sell these in the store. Again, we weren't prepared to have them for you guys, but that's my bad. So I'm going to show you some practice ones on the radar plotting sheet. You can also do them on a maneuvering board. I think I sent you a PDF of a maneuvering board.
Yeah.
So you could print those out and use those. Maneuvering boards and radar plotting sheets are the same. You can use them for the same things. This one just has a little more clutter on it, which once you get to know it, it's useful, but for beginners, I like to use this one just because it's a little more simpler. And then you have the universal plotting sheet, which you can use as well. They have the scale and your directions. If you're taking the celestial class with me, we'll be doing, here's an example of a celestial plot on a universal plotting sheet. Okay, let me move this. Put that down there. Okay. Okay, so I am going to go back to our, let's write down. We have a current. Okay, sorry, I'm writing this all down here. We have a set and drift of 200 degrees at 2 knots. The navigator wishes to make good a course of 300 degrees at 10 knots. What should you steer? Okay. So, okay, so I always make my little table. So I have my made good, I have my boat, and I have my current. Those are my 3 sides of the triangle. I have the length and direction of 2 of the sides. So now I need to find out what is the 3rd side of the triangle, or my boat. So I'm going to put it on this radar plotting sheet. So my course made good, I want to make good 300. So I start from the center and I find 300 and I draw a line. So this was 300, I just connected the line there. Then we can use the scale. It says distance scale. We can use the scale that says how far it is. So again, we put everything into 1 hour. So if I'm traveling 10 knots in 1 hour, I would go 10 nautical miles. So I find 10 nautical miles. Right there. Okay, so this is the end of my made good line. So that's what I want to happen. But I have this current pushing me to 200. And it is going 2 knots. So I use my dividers to get 2. So this is my current. So when I'm looking at this, here's my boat. I want to make good this line, but the current is pushing me this way. So logic would tell me that I need to steer into the current in order to make good that. So I could travel along my made good line, but I'm steering into the current. So I just do that mental check. But in order to complete the triangle, I need to, I have 3 points of the triangle. 1 point, 1 point, 1 point. So the third side of the triangle is the boat. You just connect those two. And now you can measure that line, both direction and speed. So for direction, on a radar plotting sheet or wherever you're using, you do have to always have the direction from the center. So we can get our direction, move it to the center. And this would make sense if I was on here and current was pushing me this way, I need to steer into the current. So I need to change course to about 310. Speed that I need to make, it's pretty perpendicular to what my speed is, or my made good desired speed. So I'm assuming that it's going to be pretty similar to what my desired speed was. A little bit more, 10.5. I need to make 10.5. So let's go back to our PowerPoint. We have a little animated version here. So we have our 10 nautical mile line, because that's 10 knots in the direction of 300, and then we have our current. We connect those lines to get what our boat is, and we measure that about 10.6. So we could fill in the missing pieces to our table. How do we do it following along with example number 1?
Yep.
Cool.
Okay.
So what, every time we do this, I have to use a chart, or can we do a calculation?
So you can do, well, you can do it on the chart. You can do it on all of those different things, but there isn't like a formula to do it.
Okay.
Your radar transfer plotting sheet is different than that maneuvering board that you gave us. So
yes, so now I'm going to do it on a maneuver. I'm going to do question number 2 on the maneuvering board.
okay. I'm looking to see if it has nautical miles on it. It has scales.
So the scales you can use, it's any sort of scale.
Okay, so you can use that nautical mile then.
Yes. I will show you on this one. Okay, so we have example number 2. The vessel is steering a course of 270, so it's a little bit different. We're steering a course of 270 at 8 knots. The current is 180 at 3 knots. What is the course and speed made good? So what is happening to you? So we got to remember that the made good and the current start from the same point or start from the center. So when I draw it, I'm going to draw the green one and then the purple one. So let's go to drawing it. Okay. So now we have a maneuvering board. A light on it. Oh, that light really doesn't do much. Okay. So they told us, I didn't write it down. Let's see, they said the set was 180. Forgot already. 180 at 3 knots and 270 at 8 knots. Okay. Okay, so I always put it on my table. The boat is 270 at 8 knots. The set is 180 at 3 knots. So I'm going to start with current. I'm going to draw 180. So on your maneuvering board, it's hard to see, but you do have a 1 through 10 scale on the circle itself. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you going over 10 miles, you can use the 1 to 2 scale. So that would be, this is 1, 2, 3, 4, 5, 6, 7, 8. So you can use that scale, or 3 to 1, 4 to 1, or 5 to 1, however fast you're going. But so we're just going to use the 0 to 10, the basic scale that's already on the chart. So it's kind of easy. They already showed us here that 3 is right there. So I'm going to say this is where I'll be for the 3 nautical miles. That's not right. Why is the 3 right there? I have to measure this. This is not right. So this is 10. Is it like this on everybody's? One, two. Whatever unit we're going to use this unit. This is 1. So we have 1, 2, 3. Okay, that is 3. I don't know why I was freaking out there. 3 knots. And then we have 2, 3, 4, 5, 6, 7, 8. Okay. Our next line goes from that point, right? So this line here is our current line. Our next line is the roll plotter. Is at 270. We're going to 270, but it's going from that point that we just drew. So I'm going to draw my line there, and my distance is 8. So I'm getting a measurement of 8. I'm going to bring that down. The measurement of 8. So this is what my boat is doing. This is what my current is doing.
Isn't 270 straight across from the middle?
Yes, but to put on the triangle, the ones that come from the center are the made good and the current.
So you just parallel it down?
So I just paralleled it down. Yep.
Okay, all right.
Then when you connect them, this is your made good. So as you were here and you were heading 270, right, directly west, but the current is pushing you to the south, so you crab over following our made good line of, what are we going to call that? I might call it this one. 249, 248. Okay.
So the current is actually pushing you north then, or south?
It's pushing you south. The current is 2180.
Okay.
So the
There you
current is pushing us
Okay.
south. This is our boat here. We're headed this direction.
Okay.
And then we continue headed that direction, but the current is pushing us.
Okay.
So our boat, even though we plot our boat line, which is like our DR, our boat isn't actually on that line. The wake of our boat is always on the made good line. Okay, let's go back to the graph. Okay, so we had our 3 nautical mile for our current, our 8 for our boat. What's actually happening, we are going a lot or a little bit faster. And we have 245, so I was off a little bit. 245 at 8.65. Okay, so those are my examples for the PowerPoint. Now I'm going to switch directions a little bit here. We have an online survey for this class. Let me bring you guys up here so I can see you. Okay, so Meta is going to be emailing you guys this link. Also, I'll also email it when I update this video that I'm recording. I'll send it in that email as well. But once you finish the form, you get a $10 discount. So that's a bonus. But I would really like any feedback. I won't take anything personally. Just to help this whole process better, better for you guys. So I know it's not ideal, but in some ways it works out with the online. So anyways, I just like your guys' feedback. I sent an email with practice problems, so we're gonna go over those next. But for me, my next classes are Celestial on July 8th through the 24th. And then I also am doing weekend workshops. And those are going to be on Saturdays in July and August. So that's going to be a 3-hour class, which at this point is going to be online. I'll do maybe like an hour of lecture, and then we'll have 2 hours of getting feedback from you guys. If you guys want me to do examples or more lecture on any topic that I can help you guys with. again, I'm not a recreational boater, but any sort of nav topic I can help you guys out with. And then so that's in August. And then September, we start this class again, Coastal Nav 1. So if you want to take this class again, you're welcome to. That's seven weeks. And then we have Coastal Nav 2. So our Coastal Nav 2, which is an abbreviated version of what we're doing today, is going to be probably September, 7 weeks, sometime in October. So that's for me. The other class, a lot of other students of mine like to take is the electronic navigation course. I think there's one on the website right now in June, which I heard will probably be canceled, but they are going to try to reschedule it. Hopefully they find out in a week here what our steps are going to be for having in-person classes, because the electronic navigation class, it's very cool. You get to go on all of our boats down there and play with the nav systems that we have. That is, you know, a lot of people crammed in a little cockpit. So I don't know how they're going to do that, but we will see.
Hey, Bree.
FaceTime video.
Whoop.
FaceTime video.
All right.
Bree, on that last problem that you did when you arrived at the 8.65, was that a matter of just plugging in the formula to get that number?
That was measuring that distance.
Okay.
What distance did you get?
I'm just trying to look at that chart and see where you got the 865 from.
Okay, when I bring you back to my, I'll show you. Any questions on kind of the rest of OCC? All right, well, I'm always available by email. Let's do this guy. Okay, so I will email you guys out this video and that link. For the rest of the class, really I don't have much new instruction here, but I'm gonna go over some more examples of the set and drift. I did just email you guys classwork assignment 1. I don't know why it didn't go on the other email. So I'll work through these with you guys. The first page is on maneuvering boards. And then the second page is on the chart. So I really want to get to the one on the chart. If you guys want to just keep practicing, the lapware problems I emailed are just great, great ways of practicing the set and drift questions. And again, you don't need a chart for most of these. Yeah, I don't think you need a chart for any of them. You can do them on a maneuvering board. And then if we get to it tonight, we will do assignment number 2, which is on the Long Beach chart, which has some of the set and drift on it. Okay. So let's dive into this. Okay, so Rick, for the speed that we got, go back to our thing. We
You just measured it with your divider. That's what you did?
Yes. So I measure it with a divider, and
Okay,
then measuring on this scale, because the scale is on the circle here.
Yeah.
I have 8, and then that's 8.5 and 9. So mine's just slightly past that 5.
Okay. That's all I needed to know. Thank you.
Okay. So on assignment 1, I'm gonna start with number 1. Would you guys prefer me to do them on the maneuvering boards? Because that's what you have emailed, right? Rather than the radar plotting sheets?
Yeah.
Okay. Where did my pile of maneuvering? Got it. Okay. So number 1 tells us you want to make good a course of 000 over ground. So my made good is 080 over ground. You run at a normal cruising speed, so that's going to be your boat. Your boat runs at a normal cruising speed of 10 knots. And then you have your set and drift is 140 and your drift is 4. So if you can see this, we are missing one piece of our boat's information and one piece of our made good information. So they're on 2 different lines, but they're 2 different things. It's kind of like putting a puzzle together, but we're going to walk through it here. Did everyone understand how I put my table together here?
Yep.
Okay.
Yeah.
Okay, so I know it's off screen, but I just want it to be zoomed in a little bit on this guy. Okay, so my made good comes from the center, so I'm going to have 080. I want to make good 080. This is going to be my made good line. And then I have a set with a beginning and an end to 140. At 4 knots. You know what? I'm going to use the 2-to-1 scale actually, because I'm going to go off the chart here. So I'm going to use 2-to-1. So I'm just going to circle what I'm going to use here. And I'm going to find 4 knots. So I have one point of the triangle, another point of the triangle, and this is my current line. And then the other piece of information that I haven't written down is my boat speed, and that's 10. So we're going to find our 10. So I know that my boat's line starts at my current, and it's 10. So it could be anywhere along this arc. My made good can be anywhere. I don't know what my speed made good would be. It could be here, it could be here, it could be an infinite possibilities along this line. But now that I know the length of the other line, I can complete my 3 points. So I have point 1, 2, and 3. Now I can just connect those 2 dots. And in order to measure it, we have to go to the center. So I'm just going to parallel it up to the center. So we can look at this and say, if I want to make good this, and the current is pushing me in that direction, then I need to steer this way. In order to make that good, because the current keeps pushing me. So our question is, what is our speed made good? And what is our course to steer? So this is the boat. So I measure this line, and then I brought it to the center. So my course to steer, it makes sense that I need to bring it up to the left, is about 0.60. I'll just write it on here. And then I need to figure out what my speed made good was. So speed made good is going to be on the made good line, and the speed made good is going to be the length of that line. So we're going to measure the length. We're getting a little crazy here. The length of this line. Do we think it's going to be faster than what our boat's doing or slower than what our boat's doing? Any guesses? Faster. Okay. We got about 11.5. Hmm, 1.4. Close enough. How'd you guys do on this one?
Class.
Not too bad. I was close with the 60 degrees, but I got about 12 knots.
Okay. That's pretty good.
And I just used the compass rose on the chart here.
Yeah, you can use any point on the chart.
Yeah.
Let's see. I'll do my next one on the chart. Let's do that. Okay. We're gonna go to number 2. Number 2 tells us you are reaching at 6 knots. So our boat speed is 6. And you want to make good a course. So similar setup here. You want to make good a course of 240. The set and drift have been found to be 280 at 1.5. Okay. Now I'm going to do it on the chart. So you really just make up, you guys see that still? You just kind of make up a spot. You can use the center of the compass rose. You can use an intersection here. You can use the intersection there. Really wherever you want to go. Or it could be an actual position. Let's just do it from the compass rose here. Okay, so yeah, we can do that. I lost my pencil. Oh, you can't see the compass rose. Okay, whoa. Here's our compass rose. Starting from the center, we have our course made good of 240. So I'm going to draw in a 240 line. And then I have a set of 280 at 1.5. So 280. At 1.5. So I'm just going to use the miles on my chart. So that's 1.5 nautical miles. This is my current line. And then my next piece of information is my boat line, somewhere meeting this line. I don't know where, but I know the length of it is 6. So I find 6 miles. Let's see. I made my line big enough. Nope, I didn't. I'll swing my arc. Extend this line. Barely off the chart here. So I have my 3 points of my triangle. And now I can just connect the two. This is my made good. This is my current. Now if I connect the two, I can see what my boat is. I had it here. Could use my roll plotter. Right about 230 would be what I need to steer, which makes sense. If I have the current, made good, current is pushing me to 180, so I need to steer into the current. So I need to go left, 230. So again, you can do this on graph paper, anything. I just designed this worksheet so you can make it just really get the concept of the vector triangle down in a simpler way, because on the chart, things get busy. Okay, let me do one more on this and then we'll get to the chart. Let's see, which one do I want to do? Do you see what should you do? I didn't do any tricky ones on here. Okay. Let's go to 12:10. What time is it? Let's actually take a 10-minute break here. I have to clear off my chart and move it so you can see the problem here. So let's come back at, what do we got? 7:45? Yeah, just before 8. And we'll get started again.
Okay.
Thank you.
Thank you.
Back to recording. My chart. There it is. Got it. Okay. Okay. So 6, 7, and 8 on our assignment 1, we do our chart plotting on the chart itself. So for number 1, it tells us we departed Breton Reef Light, and we had a course of 100 at 8 knots. And then at 10:45, we got a fix. And then it asks us, what is our set and drift? What was the speed made good and course made good? So we're just going to plot out the information that they gave us. This is my better one. So they told us we were on a course of 110 degrees true from Breton Reef Light. So I put my pencil on Breton Reef Light, and then I get 110. So on my meridian, I have my focal point and 110. I'm gonna draw it a little bit further, just in case. Can't remember. So here I have 110 degrees true is my course, and my speed is 8 knots. So I got a position at 10:45. Right, where's my paper? Oh yeah, here it is. 9:45, 10:45. So in that time, how far would I have traveled? 8 nautical miles in 1 hour, right? We left here at 9:45. At 10:45, that would be 8 nautical miles according to our $60D Street. So this is just a regular old DR. That's 4 miles. 8 miles. Okay. Can you see that? Okay, so this was 9:45, and this is my DR at 10:45. Just using my course and my speed. I plotted my DR position. Now I'm gonna find my actual position. I got a GPS fix, so I need to plot that. Was 22.5, 22.5. And 15. Oh, I did. Okay. So this was my actual position at 10:45. Some of these lines make it less confusing. Okay, so looking back in the last hour, this was at 9:45, this is at 10:45, where I thought it'd be. That's where I actually am. So somehow I've drifted south of my track line, and I haven't made as good a speed as I would have liked. So if I bring this to the vector triangle, I can call this line my boat line. From a known position to the next known position, that's going to be my average of what I made good. Right, so I might have swiveled a little bit here and there, but on average, in 1 hour, I was at this point and then I was at this point. So I made good this line. This is what my boat was steering. So this line, if I connect these two dots, that is what my current is. So now that we have these lines, we need to measure them. So on our question, it said, what was the set and drift? So remember, current is 2. So it's going, if I was headed this way and I drifted to the south and didn't make enough speed, the current would be pushing me to this direction. If I could put an arrow on it. The current is pushing me that way. So when I get my current lined up, what I get, 257? Oh, nailed it. So I line up my current, put it on the meridian, and down at the bottom, it could either be 257 or 077. Now 077 would be in this direction. 257 would be in this direction. So we always got to keep that in mind that it's going to. So we have 257 is the direction of the current. And the speed of the current, we measure the distance there. And remember, it's all in 1 hour, so we can use this distance. So I have 1.2 as my distance. So 1.2 knots would be the speed of this vector. Any questions so far? Okay. The next part of the question is, what was my course made good and my speed made good? So we've gotten this question before a couple times. From a known position to your new known position, what actually happened? What was the made good? So all we do is measure this line. We have the line already. It's crossing the meridian there. They got a made good of about 115, 116, 115. And then I measure the distance of this leg, and it's in an hour, so your distance is equal to speed. I'm gonna move it to, oh, I got exact. So that's 1, 2, 3, 7. So I'm not making as good speed, right? This is slowing me down a bit. Yep, 7. So I'm made good 7 knots at 116. And then if you wanted to move on, this isn't part of the question, but let's continue on. If you wanted to, let's see, how am I going to do this? This is your known position now. You want to apply your current, and you want to make good, right? We're drawing our line that we want to make good. Where can you see us on the chart? Can you see buzzards? No, you can't see buzzards. Here. Can you see buzzards light now? Yeah. So this was our, move it over. Okay, everyone still with me?
Yeah.
Okay. So this was our 1045. I want to go to buzzards. What course should I steer using this current? I would connect the lines or connect the two dots. So this is my made good. And then I apply my current. So my current starts from my made good as well. So my current basically extends itself out that way. Point 2. So this is now my current line because it's going to that direction. 2. I don't know why it's sounding weird. And now if I connect this dot, so not my made good dot, to my Brenton Reef, I can get what my course to steer would be. Ooh. Which is very close, as you can see, to my, I shouldn't have picked Brenton Reef. I should have picked something down here, Brown's Ledge or something. That would make a better triangle. Okay. Sorry for the confusion here. I'm going to erase my Brenton Reef line. That's going to bring us straight down there. I don't know. I'm not going to make up a problem. That was a fail. Let's do another problem. Any questions so far? Okay, let's do another problem and we can make one up better from that position. I'm going to skip to number 8 and then go back to number 7 because number 7 is a little bit tricky. So I'm skipping to number 8 if you're following along. Okay, so we are, number 8 says, we are headed eastbound on the south side of Martha's Vineyard. So we're on the south side of Martha's Vineyard, headed eastbound, around to Cape Cod, up and around. At 1800, you depart the buoy on the south side of Martha's Vineyard, buoy number 2. So that would be this buoy. And we depart at 1800. Depart the buoy at 1800. On a course of 090 at 5 knots. I'm going to make a course. Zero 090. Five knots in an hour, 1900, would give me here. So I have a departure at 1800 and a DR for 1900. So this is my, make sure I put it on the right side here. This is my boats line. I'm not gonna write it just yet. Then we get a fix. Of course we do. I'm real close to the line here, so I can just use the triangle. We get a fix of 70 degrees 42. So 1, 2. And 12.2. So 11, 12.2. Aha! We have another line. Man, I really wanted to trick you with these, didn't I? All right.
Stumping the teacher too.
I know.
Luckily, it's our last class.
Okay. Well, it's just not a great way to demonstrate it.
Good way to go out, Bree.
I know. What am I gonna do? Okay. So let's draw this on the whiteboard. Let's make it
There you
simple.
go. There you go.
There we go. Oh man, we're gonna have to end this. Okay. We got the buoy. We got our course. What's our speed? 5 knots? So we have a DR. So this is what our boat is doing. But we got a fix right about here. This was 1800, this was 1900. So we connect our 1800.
Hey, Bree, what was our fix again?
What was that question?
What was our fix again?
Our fix was in Latin long. Oh, it was 41 degrees, 12.5 north, and 070 degrees, 42.0 west. So with our lines, we have a very flat triangle. So this is our current. Made good. And boat. So our triangle is real long and skinny. Which brings us to our next question where we don't even have a triangle. But maybe that's why I had this as the last one. Anyways, we can measure the difference between our DR and our actual position to get the current. So you can measure those two. And then to get made good, you measure what happened from the known position to the other known position. Now, what I want to go over is, let me erase this. What happens when our triangle turns to a, so this was our made good. Just gonna stretch it out a little bit here. more simpler triangle, right? What happens when it gets completely flat, and how do we measure that? And what I mean by completely flat is if you have a following current, which means it's directly on your stern, so it's pushing you along, or a head-on current, you're stemming the current. That means it's directly on the bow, really slowing you down. You're stemming the current. I don't know if I spelled that right. Head-on. So let's draw those out. If we have our made good, or let me start with boat. If we have our boat going this way, and our current also going this way, our made good would be a whole lot faster, right? It's a following current, it's pushing us along. So our made good is really fast. So this would be our following current. If we had a head-on current, our boat would be traveling like this. But the current would be directly pushing at us. So our made good would be a whole lot smaller. We'd be going slower than what our boat is actually doing. So our triangle can really, which we've seen here in the last two examples that I've tried to do, is get a flat old line, which is a little bit harder to visualize, but once you get the concept of the triangle, you can differentiate the line, if you will. Does that make sense?
Mm-hmm.
Yep.
Okay.
Yeah.
Okay, so now I'm gonna throw you a real tricky one. We're going up to Buzzards Bay. Now I'm gonna have to lean over my chart too, so it's gonna be tricky. Woo. What makes this one tricky is that it's not on the hour. I have made it 40 minutes. So 40 minutes is not on the hour. Then we need to do 60 D Street for every leg, for every side of the triangle. Doesn't that sound fun? Okay. We were at buoy 11. Can you see buoy 11? No, you can't. Okay. I'm gonna try to do this. This is buoy 11. Okay, you can see that. You can see the tower. Okay. Focus. There we go. Okay, so I'm on number 7. Number 7 tells us you're in Buzzards Bay. This is Buzzards Bay. And at 12:20, you pass very close to buoy 11. We're going to call this 12:20. We're at buoy 11. And then you are steady on 220. I'm not going to reach, so I will go here. 220 true. Yep, gave us 220 true. Okay. Yep, 220. 220 true at 4 knots. Okay, and then at 1300, it gave us a position. So first, I want to do a DR to 1300. So 1300 minus 1220 gives me 40 minutes. How far did I travel in 40 minutes? I have a speed of 4 knots. I have a time of 40 minutes. So I need a distance. Distance equals speed times time divided by 60. Oops. Plug in our numbers here. 4 times 40 divided by 60. What does distance equal? .666 nautical miles. Okay, so now we can plot that. Here's my question here. Okay, so I think I'm going to be right here at 1300. With me so far, that's the DR. But it tells me at 1300, we are a beam of West End Tower, and we get a fix. And the fix is a beam fix, 310. The lookout tower here. .310 at 2.5, not 2.5 distance. Which would put me right on the line. So I'm actually here at 1300. So my line, I'll bring it back to making it good. Current. So. Back to them. Okay, so I'm bringing it back to my markers again. I have my boat that I made good is actually a lot longer. So my current would have to connect the two. So we get this line. Do we see it? We have what our boat is doing, what our made good is, and what our current is. So is this a following current or a head-on current?
Following.
Following, right? We went a lot further than we thought we'd go. So now the question is, how fast is this current? That's where we get back to our 60D street. And what is our speed made good, course made good? So, pencil here. This line is my current. This line is my made good. So what do we see first? Our first one is, what is the set and drift? So first we're going to measure the current. So we know the direction is 220. The distance we need to measure I got 1.3. So I have a distance of 1.3, a time of 40 minutes. What was my drift? What was the speed of my current? So I go to my 60D straight. Gives me a drift of 1.95 knots. So I have a following current of almost 2 knots. Do you see how we had to put our distance back into 60D street because our time was not 1 hour?
Yeah.
Okay. So we got to do the same thing when we're looking for our speed made good. Our speed made good course is the same, 220, because it's a following current. But for speed, we have to measure it and then convert it. So I got a distance of 4. A time of 40 minutes, a speed of question mark. So time gives me speed. So our speed made good is a lot faster than what our boat's speed was. 6 by almost the 2. So we're kind of adding and subtracting these vectors on a line. So that makes sense. If this was 4, this was 2, this would be 6. But it's very tempting to just measure that and say that's what it is, because not everything is on the hour. It's great when it is. So that's why I like to say, get your plots on the hour or on the 6-minute mark. But in reality, it doesn't always happen like that. So we have to go back to 60 D Street. All right. Any questions on that?
Bree, if you measure that distance from the chart directly and divide it by 40 and times 60, that give you speed, right?
Yes.
Okay. Yeah.
I think I was following you on that. Okay.
Next one. Oops, I may have lost you.
What's up, Janice?
Oh, I just wanted to say, if you're sailing upwind and you think that you're making significant leeway, using these set and drift vector triangles is a good way to figure out how much leeway you're making, so that it will help you know when to tack. You may realize that you're getting pushed downwind or to leeway more than you had hoped. And so you may decide that you have to tack sooner or tack more frequently. But a way to get an idea of how much leeway you're making and you're dealing with is by using these set and drift vector triangles. So if someone is on a short day, you might just see that you need to tack a couple extra times. But if you're on a long trip where you might be out there sailing for more than a day, keeping track of this leeway is going to keep you on course better and get you to where you're going better.
Yeah,
So
definitely. All right, thank you. That's all I'm gonna do for tonight. Again, in October, we start CoNav1, which is a 4-week course. So it'll be all of this, but in 4 weeks. So a little bit slower. And we didn't get into calculating tides today, which everyone has an app on their phone and does it by phone. Or computer, or already has it on their chart plotter on the boat. But it's just a different way to read the little chart book or calculate tide wherever you are. So we do spend a week on that in CoNav2. And then our last class of CoNav2, we go over electronic navigation, just kind of the theory behind it. So that's all I got for you guys. Thank you for bearing with me on this online coronavirus time. Hopefully I will meet you guys in person one day. I'll be around OCC.
Yeah.
All right.
Yeah.
I just want to add that check the homepage for occsailing.com in about a week and see if there's any updates.
Okay, we should get more updates in a
Meta's
week.
trying to keep be something. Yeah. Meta's trying to keep the page updated as she learns things. So doesn't hurt to check back and see what the latest news is.
All right.
Okay. All right.
And thank you
All right.
very much.
Sounds good.
This
Thank you.
was wonderful.
Yeah.
Thank you guys.
Thank you,
Thank
Bree.
you.
Thanks, Bree. Thanks, everybody.
Bye.
There'll be notices about that electronic navigation course too, right?
Yeah,
Hopefully.
on the website.
Okay. Very good.
Yeah, I'm sure in a week, I think at that meeting, they're gonna have more answers to our questions.
Okay, great. Thanks a lot.
All right, bye.
Good night.
Thank you.